This is 7.4B&C from OpenStax, Algebra and Trigonometry. First, we're going to look at section B, using reference angles to evaluate tangent, secant, cosecant, and cotangent. So before we talk about that, we need to review some concepts that we learned previously. In 7.3e, we learned how to find sine and cosine of an angle using the reference angle. If you need to go back, there is a video that you can watch to review that. But real quick, by way of review, here are some of the graphs and charts that we used when we were talking about that. What we said was that if you just focused on the first quadrant angles, focusing on the special angles, and if you just learned how to find the value of sine and cosine there, then you could apply it to the other quadrants based on whether or not the value of the x and the y are positive or negative in the other quadrants. So we said, for example, in quadrant 1, we know that all the x's are positive and all the y's are also positive. And so we would have positive x and y values for all of these points. But then we could extrapolate that to the other quadrants. In quadrant 2, you would have a negative x and a positive y. In quadrant 3, you would have both of them negative x and negative y, and then in quadrant 4, you would have a positive x and a negative y. And so you would have the same value as far as your sine and your cosine. You would just change the sign, the positive or the negative, depending on which quadrant your terminal angle was in. So now we're going to do that same thing, but we're going to do that with tangent, secant, cosecant, and cotangent. Like I said, if you need to go back and review that, that would be in 7.3e. So we can use the same method for finding the other trig functions. First, you're going to find the reference angle. Remember, the reference angle is the angle between your terminal angle and the closest x-axis. The values of the original angle will be the same as the value of the reference angle. The only difference would be the positive or the negative, and you would determine the positive or negative depending on the quadrant. And so this is one way that you can remember it. So what this is, this graph shows you where the different trig functions are positive. Okay, so in quadrant 1, all of the trig functions are positive. Okay, any angle within quadrant 1 is going to have positive sine, positive cosine, positive tangent, positive secant, positive cosecant, and positive cotangent, because x and y are both positive in that quadrant. In quadrant 2, only the sine and its reciprocal are going to be positive. In quadrant 3, only tangent and its reciprocal are going to be positive, and in quadrant 4, only cosine and its reciprocal are going to be positive. Okay, so how can you remember this? This is an easy way to remember this. We're going to start in quadrant 1, and we're going to work our way around, and we're going to come up with a mnemonic device. Okay, so the mnemonic device is A for all, smart for sine, trig for tangent, and class for cosine. So our sentence says a smart trig class. That's what you guys are, okay? So a smart trig class. So you know that in quadrant 1, they are all positive. In quadrant 2, sine and its reciprocal are positive. Quadrant 3, tangent and its reciprocal are positive. And in quadrant 4, cosine and its reciprocal are positive. A smart trig class. Write that down, put it somewhere where you'll see it, memorize it, okay? A smart trig class. And remember, that doesn't go in our normal reading order, it goes in order of the quadrants. Quadrant 1, 2, 3, 4. So let's go ahead and put this to use. Example 3. Use reference angles to find all 6 trigonometric functions of negative pi over 6. Negative pi over 6. So the first thing we need to do is we need to find our reference angle. Let me just sketch this real quick. Okay, so if we're doing negative pi over 6, that means we're starting here and we're moving our way this direction. It's negative. Okay, and we know from here to here it's going to be negative pi, which is negative 6 pi over pi. And so we are dealing with approximately sketched, so not perfect, this angle. Okay, so let's go ahead and, so our t is negative 5 pi over 6, but we want to use the reference angle, right? So the reference angle is from that terminal side to the closest x-axis, which would be here. And then we can put that same reference angle in quadrant 1. Okay, so our reference angle, the angle from here to here, right, and previously we called it t prime, the reference angle is pi over 6. And we also talked about the equations and formulas to figure that out. And so we're going to work with pi over 6 in order to find the 6 trigonometric functions. So what we're going to do is we're going to, we can go ahead and label this out because we know you can pull out your reference chart, you can pull out that diagram of all the angles in the quadrant 1 to come up with these. But what we know is we know that this is 1, this is 1/2, and this is, I'm going to squeeze it in there, square root of 3 over 2. Okay, so that's square root of 3 over 2. And so we can come up with all the 6 trigonometric functions of the reference angle. Okay, so we're going to say sine of, and we said the reference angle was pi over 6. Sine of pi over 6 is 1/2. Cosecant of pi over 6 is equal to 2, right, because it's the reciprocal. Cosine of pi over 6 is equal to square root of 3 over 2. Secant of pi over 6 is equal to 2 square root of 3 over 3. Tangent of pi over 6 is equal to square root of 3 over 3. And cotangent of pi over 6 is equal to square root of 3. Okay, so now if you don't know where I'm getting these, you need to go back and review how we find those for the special angles in quadrant 1. But I'm assuming that you already know how to do that. Okay, if you need me to reference you back to something, let me know and I'll send you the correct videos or the correct lessons. Okay, so we have found the 6 trigonometric functions of pi over 6. Okay, that is our reference angle. But that's not actually what we've been asked to do. We have been asked to find the 6 trigonometric functions of negative pi over 6. But we know that they're going to have the same numerical values as the reference angle, but just the signs are going to be different. Okay, so our actual angle is in quadrant 3. Quadrant 3. Okay, so what functions are positive and what functions are negative in quadrant 3? Well, we know that a smart trig class. Okay, therefore we know that in this quadrant where our terminal angle is, tangent and its reciprocal, cotangent, those are going to be positive and everything else is going to be negative. So now we can use these values that we got for the reference angle and just add the appropriate signs. So therefore we know that the sine of negative 5 pi over 6 is the same number, but it's not tangent or cotangent, so we have to add a negative, is negative 1/2. Cosecant of negative 5 pi over 6 is also going to be negative, so it's going to be negative 2. Cosine of negative 5 pi over 6, also negative, put a negative in front of there, negative square root of 3 over 2. Secant, negative 5 pi over 6 is this same value but negative, negative 2 square root of 3 over 3. Now here's where we get, these ones are positive, so we do not change these. These are going to stay positive. Tangent of negative 5 pi over 6 is equal to square root of 3 over 3, and cotangent of negative 5 pi over 6 is equal to square root of 3. Okay, so that's how we use the reference angle, pi over 6, in order to find the trigonometric functions of an angle that is not within the first quadrant. Okay, now I'm going to put up a try it problem for you. Try it number 3. Use reference angles to find all 6 trigonometric functions of negative 7 pi over 4. Now, it's a little frustrating that they gave you this one for a try it, because let's go ahead and figure out where negative 7 pi over 4 is. Okay, so we're going the negative direction, so we're going this way. Okay, so we're going to find the reference angle. We know that if we go from here to here, that's negative 4 pi over 4, because that's 1 pi. And if we go all the way around, that's 2 pi, which is 8 pi, negative 8 pi over 4. So we're dealing with this one right here. This is negative 7 pi over 4. And that means our reference angle here, so this is t, our t prime is equal to pi over 4. Okay, so we're just going to use pi over 4 to find all your trig functions of negative 7 pi over 4. And of course, because this reference angle ends up in the first quadrant, you don't need to change any of the signs. Which ones are going to be positive in the first quadrant? They're all going to be positive in the first quadrant. Go ahead and pause the video and figure out all the 6 trigonometric functions of pi over 4, which would then therefore be the same as the trigonometric functions of negative 7 pi over 4, and then come back and check your answers. So let's go ahead and write these out. We have the sine. Now last time I did the reference angle and then the actual angle. We're going to just do them all together. So we have the sine of pi over 4 is equal to the sine of negative 7 pi over 4, right? Because those are the same angle. The reference angle is the same as the terminal angle. We're just using the positive instead of the negative. And that is going to equal square root of 2 over 2. Cosecant of pi over 4 is equal to cosecant of negative 7 pi over 4, which is equal to the square root of 2. Cosine of pi over 4 is equal to the cosine of negative 7 pi over 4, which is equal to square root of 2 over 2. Secant of pi over 4 is equal to secant of negative 7 pi over 4, which is equal to square root of 2. Tangent of pi over 4 is equal to tangent of negative 7 pi over 4, which is equal to 1. And cotangent of pi over 4 is equal to cotangent of negative 7 pi over 4, which equals 1 as well. Okay, so check your answers and see if you got that right. So hopefully you see why the sine of the reference angle is the same as the sine of the original angle, because they both end up in the first quadrant. The reference angle is always in the first quadrant, but the original angle happens to be in the first quadrant in this one. If you have any questions, please let me know. Moving on to section C, using even and odd trigonometric functions. I forgot to animate this all correctly. But just by way of reminder, so this is going way back to the beginning of the year when we talked about functions and how functions work and how we can define them. Remember that if f of x is equal to f of negative x, then the function is even. So if we plug in a negative x, we get the same output as if we'd plugged in a positive x. So that would be like a quadratic equation, right? If we plug in a positive 2, we get 4. If we plug in a negative 2, we also get 4. So remember, you can test whether a function is even or odd with this. If this is true, then it is even. Also, if it's reflected across, if there's a reflection across the y-axis, there we go, then you know that it is even. Okay. Remember, if you plug in that negative x and the whole thing becomes negative, negative f of x is equal to f of negative x, then the function is odd. And so if we plug in positive 1 then you get out positive 1. If you plug in negative 1, you get out negative 1. And remember, this is a reflection across both axes. First you reflect it across, well, it doesn't matter which one you do first, but you reflect it across the y-axis and the x-axis, and then it is an odd function. Now remember, functions don't have to be even or odd. They can be neither, but right now we're just going to focus on even and odd functions. So now we're going to look at the evenness or the oddness of the trig functions. So let's go ahead and define this. Cosine and secant are even. Cosine and secant are even. So if you put in a negative of the negative of an angle into the cosine, you will get the same value as the positive of that same angle, right? Because the x's are both positive on the positive y. Same thing is true for its reciprocal. Okay, so cosine and its reciprocal are both even functions. The remaining functions are all odd. Sine, tangent, cosecant, and cotangent are all odd. So sine of negative t is equal to negative sine t. Cosecant of negative t is equal to negative cosecant t. Tangent of negative t is equal to negative tangent of t. And cotangent of negative t is equal to negative cotangent of t. Okay, so make sure you write this down and have this so you can reference it, which ones are even and which ones are odd. It would be beneficial to memorize that cosine and its reciprocal, cosine and secant, are both even and the rest are odd. Let's see what this looks like in practice. Example 4. If the secant of angle t is 2, what is the secant of negative t? So before we begin, let's go back and look at secant. Okay, secant is even. Okay, so I know that secant of negative t is equal to secant of t. So I'm going to go ahead and write that just as a reminder for myself. So I know that secant of negative t is equal to secant of t. Okay, so it says if the secant of angle t is 2, secant of t is equal to 2, what is the secant of negative t? Secant of negative t equals, and that's what I'm trying to figure out. Okay, but I know that secant of negative t is equal to the secant of t because it is an even function. Therefore, secant of t is equal to secant of negative t, and we know that the secant of t is equal to 2, so the secant of negative t is also equal to 2. Okay, let's look at another problem with this. Try it number 4. If the cotangent of angle t is square root of 3, what is the cotangent of negative t? So real quick, I'm going to go back a few slides. Here we go. So we're dealing with cotangent. Cotangent is an odd function, okay? So cotangent of negative t is equal to the negative cotangent of t. So let me come back here, and I'm going to go ahead and write that here. Cotangent of negative t is equal to negative cotangent of t. Okay, so if the cotangent of angle t equals square root of 3, what is the cotangent of negative t? So we're given that the cotangent of t is equal to square root of 3, and we need to know what the cotangent of negative t equals. Okay, pause the video, see if you can figure that out, and then come back. Okay, so if the cotangent of t is equal to negative 3, and then we change t to a negative, then we know that we have to put a negative in front of the whole function, cotangent, negative cotangent of t, and we know that cotangent of t is square root of 3, so negative square root of 3. So the cotangent of negative t is negative square root of 3. Let me know if you have any questions. If you need review on any of these concepts, if you need review of even or odd or of reference angles, please let me know. Check Google Classroom for your assignment.